Wow.
We are here today at Science Space to observe this Foucault pendulum. The globe model claims that this device can be used to demonstrate the Coriolis effect and therefore prove that Earth is rotating. Let's explore what the globe claim actually is. What is happening? As the pendulum swings back and forth, the Earth is rotating. An astronaut in space watching a pendulum at the North Pole would see the direction of the pendulum remain the same, but the Earth would turn below it once every day. We are standing on the rotating Earth, therefore we see the pendulum change direction. We are not at the North Pole, so our pendulum takes more than one day to complete a full rotation. A pendulum actually rotates slower the closer you move to the equator. At the equator itself, it doesn't rotate at all. The diagram in the bottom left represents what the globe claims a pendulum will do at the North Pole, in Paris, and at the equator. Being here in Sydney, we should observe the pendulum rotate 202 degrees in 24 hours. In the top left, we are also given an activity to do. What to do? Work out which domino is going to be knocked over next. The pendulum will appear to move counterclockwise. And being in Sydney, the globe claims that the pendulum will precess at a rate of 8.5 degrees per hour counterclockwise. So let's put this to the test, shall we? This is the starting position of the pendulum. The globe predicts it will precess counterclockwise 8.5 degrees after 1 hour, knocking over the dominoes with the blue X's, 17 degrees after 2 hours, knocking over a further 2 dominoes in purple, 25.5 degrees after 3 hours, taking out another 2 dominoes in green, and 34 degrees after 4 hours. We will be observing this Foucault pendulum for 4 hours, so the globe predicts we will see a total deviation of 34 degrees and a total of 6 dominoes on each side be knocked over. Beginning the observation at 9:11 a.m, this is the starting position of the pendulum. The globe predicts it will deviate counterclockwise. At 10:11 a.m, this is what we observe in the pendulum. The globe predicted that the pendulum should have deviated 8.5 degrees in that first hour, but it is still on the same starting position. At 11:33 a.m, we see the pendulum still in the starting position. The globe predicted after 2 hours, it should have deviated 17 degrees and knocked over the dominoes highlighted. 10:12 p.m. and the pendulum is still in the starting position. After 3 hours, the globe predicted it would have deviated 25.5 degrees. And finally, at 1:16 p.m, the pendulum is still yet to show any sign of deviation. The globe claimed after 4 hours it should have deviated 34 degrees and knocked over a total of 6 dominoes on each side. So what is the conclusion that we can draw from this observation? Let's formulate a modus tollens valid logical argument. If P, then Q, not Q, therefore not P. And just to confirm, this is the claim of the globe, that we are standing on the rotating Earth, therefore we see the pendulum change direction. The modus tollens argument will be as follows. If the Earth we're standing on is rotating, then we will see the pendulum change direction. From the observations of the pendulum for 4 hours without any deviation, we can then conclude we don't see the pendulum change direction. Therefore, Earth is not rotating. So the next time someone claims that the Foucault pendulum proves that Earth is rotating, point them to this video and just let them know the Foucault pendulum proves Earth is stationary.
Wow.